Alright, welcome to the Computer Number Systems video series. This is video 2, the binary number system, in which we're going to look at what the binary number system is, and we're going to do some playing around with the binary number system. We're not going to do any conversion between number systems just yet. I want you to get used to the binary number system. And the way I'm doing this video series is I'm kind of making one video about one subject and then moving on to another video. That way, if you need to review a certain topic, you can just pick that video out of the list and you're good. You don't have to scroll through a 45-minute video presentation to get the information you need. I know I hate that, and I hope you enjoy the way I'm splitting these videos up. Alright, so we're going to look at the binary number system. The binary number system is a base 2 number system. If you remember from the last video, the decimal number system is a base 10 number system. Well, binary is just a base 2 number system, and it uses the digits 0 and 1. That's the only two digits in the binary number system. Alright, now this may seem a little foreign to you, and if you've never messed with it before, it should. But the computer systems use the binary number system. All right, and we generally represent false or off with 0, and we represent true or on with the number 1. Okay, so we have to understand the binary number system to really become good with computers, whether you're networking or whether you're programming or something like that. It just helps to know the binary number system. Okay, and if you get this base information, this base process down, you'll be much better off than people that don't. Alright, I've seen it before in industry. You get people that just aren't familiar with binary, never really learned it in school or learned it half-heartedly, and they're at a loss when certain things happen. Okay? So the question arises, if it only uses two numbers, then how the heck does this number system work? And that's kind of what really threw me at first when I was thrown into binary is, well, then how does the whole number system work if it only uses zeros and ones? Well, the way it works is, instead of stringing numbers 0 through 9 together, we string zeros and ones. Okay, an example of this here is this binary number here. Now, true, I don't need the leading 0 here. I just threw it in for an example. But a binary number could be 0, 1, 1, 0, 0, 0, 1, 1. Alright, well, what's the value of that binary number? Meaning, what does it represent? How is it human readable? Okay, and to answer this, we must learn how to convert between number systems. Alright, so we're going to learn how to convert between binary and decimal. Alright, and when you get to the end of this video, you should be familiar with it. Alright, so the solution to this is the following. Okay, I do just like I did with the decimal number system in the previous video. If you have to go back and watch that video, watch that video. Okay, don't be afraid to watch videos 3-4 times if you need to until you get the information down. Alright, just like in the decimal video, I take the leftmost number, I put it in the first row here, and every subsequent digit I put in the row beneath it. Make sure you don't get your ones and zeros transposed and you're counting them out right and everything like that. Alright, I left the leading 0 in there for a reason, which I'll get to later. And then I go over, when I'm at the last number, I go over to the next cell in the table, and I put 2 to the 0 power. And then each subsequent row I go up, I increase the exponent value by 1, all the way up to 2 to the 7th power here. Alright? And then once you do all the math, once you do all the I didn't carry the exponents out like I did in the last table because it would have gotten really huge. 2 to the 7th power is equal to 128 if you do the math. Alright, well, you have 0 times 128, which is 0. 2 to the 6th power is 64. 1 times 64 is 64. And as you're going down the table, the next value is equal to half of the previous value. And you just do the multiplication as you go down the table here. And then once you're done doing all the multiplication, you add up all the values here. 64 plus 32 is 96, plus 2 is 98, plus 1 is 99. So we can say that this binary number has a decimal equivalent of 99. Alright, really cool stuff. I want you guys to know how this works. Pause the video, take a look at the table, be adept at looking at this. Again, I just want you to go down one side, you go up the next column, go down one column, go up the next column, and then do the math. Alright, and then you add up the results, and you get 99 in this example. Okay, pretty cool stuff. I'm going to show you how to use Windows Calculator to do this as well. Alright, so 0, 1, 1, 0, 0, 0, 1, 1. We're going to check that answer out in Windows Calculator at the end of the video. Alright, pretty neat, huh? In the next video, we're going to look at converting from decimal to binary. We're going to look at converting from decimal to binary instead of converting from binary to decimal. If you ever want to check your answers, right, all you have to do is start your calculator in Windows. Alright, and now when you first start your calculator, it's going to look like, I use Cam Studio for the video. It's a really neat program. Let me minimize that. There we go. Your calculator will start in standard mode like this typically. What I want you to do is I want you to click View and Programmer. There we go. And this expands the look of your calculator out. You'll see these 4 things over here. You'll see the little dot next to decimal. Okay? Well, I can put 99 in for decimal, and I can convert it to binary just by clicking the BIN option there. And, well, what do you know? 110011. It doesn't give us the leading 0. I just used the leading 0, so I would have 8 bits or 8 binary digits to work with. Alright, the binary digits are typically called bits. There's 8 bits in a byte. And this is all computer nomenclature. We're just going over the mathematics behind it right now. So sometimes it helps to read from the right to left instead of left to right, so you know you have the right number. 11000011. Yep, hey, that works. Our answer was correct. Now, if you have to watch this video again, a 3rd or 4th time, watch it as many times as necessary to get the concept down. Alright, I look forward to hearing from you in the next video. Thank you so much for watching.